Hi, this is Shah, VP Research and co-founder at Counterpoint Research, and we are here at Qualcomm booth at MWC Barcelona, seeing a lot of new innovations, and we'll talk to Mr. Durga Malladi, and maybe Durga, you can introduce yourself.
Yes, Durga Malladi, EVP and GM at Qualcomm, responsible for our technology planning, edge solutions, and data center.
Wow, that is a long list of responsibilities, and so yeah, talking about long list, I've been at the booth, and again, it's always expansive. You have everything from IoT to now data center. And earlier it used to be a lot of connectivity, but connectivity has gone in the background. But now it's again coming back in the foreground, but it's very different this time, right? Can you talk about 6G, what you're talking about in the booth and elsewhere?
Yes, first of all, always good to see you, Neil.
Yes.
And it feels like just yesterday I just met you at the AI Summit. So let me unpack a few things that we did this year. It's the 20th edition of Mobile World Congress in Barcelona. And I didn't know about that, but it is quite something. It's been a long time over here. And 7 years back, it was around this time that we talked about 5G launches in Barcelona. And I want to go back to why are we talking about 6G and what is so new about it and what is
Right.
different compared to 5G, because it's important to have that context so it becomes clear as to what 6G really means.
Yeah.
At the same time that 5G launches were occurring, there was something else that was happening in parallel, and that is an AI technology that was expanding dramatically in fast moving pace concurrently with the 5G deployments. The first transformer networks were talked about in 2018. So at the time 5G launches were occurring, there was a second transformer network. Fast forward about 2-3 years later, when GPT was becoming mainstream, and we invested heavily in compute.
Yeah.
We've been doing that for a while, but we really invested heavily in compute, specifically focusing on AI inference at the edge,
Yeah.
all kinds of devices, while continuing to march on 5G as well. But at that point, we were beginning to see that it is only inevitable that there must be a way of bringing in both of these and a new G that incorporates the best of everything that we have done in cellular so far, but also bringing in elements from what we have done on AI, across the industry and especially for Qualcomm. So when we started putting things together, we kind of outlined the vision of 6G, the blueprint of 6G, with 3 pillars.
Okay.
The first pillar is connectivity. It's what one expects with a G transition.
Sure.
Better coverage, better capacity, better user experience, with one twist though. The kinds of use cases that are emerging with the new devices, let's take your AR glasses. If you want your AR glasses to be connected directly via cellular network, then all of a sudden when you wear the glasses and let's say you're in a call and you're in that see what I see kind of a mode, the uplink traffic is much more heavy. In fact, you're not streaming anything in the downlink. It's primarily uplink. It's a very different kind of a network. Second, the UI to those devices is all actually based on voice.
Yeah.
And there's a lot of AI processing that occurs in the devices as well. So there's a heavy dosage of AI in devices, but you might also want to rely upon the edge of the network to do some of the processing. Very different kind of, it's still connectivity, but very different kind of connectivity. Second pillar is, well, what else do you do with all these new bands that we are talking of or new channel bandwidths? Wide area sensing is now going to become mainstream moving forwards. In fact, you don't even have to wait for the standards to be completed. Right here in our booth, we have a demo that shows if you do wide area sensing, and what I mean by that is the ability to have a bird's eye view of everything that's happening in the network. There's all sorts of use cases that come in. A few years back, we used to talk of wireless LAN-based RF sensing.
Right.
You can detect your heart rate, you can detect the way you walk, and based on that, whether it's an intruder or not. This is different. If you can detect and classify objects in the sky, you can detect drones in the sky. That's one of the demos that we are showing, which means there are certain elements of the defense industry that could be interested. If you see everything from a traffic management standpoint, you can actually use that data and process it and do other things from a whole traffic management standpoint. Similarly, airports can use these things. Basically, your national wireless telecom network becomes much more than just providing data services. It augments a lot of other services. That's pillar number 2. Pillar number 3 is There's so much of data coming in. What do you do with all that data? Option number one, well, ship it to a data center. That's always an option. And that's a place where, well, the data centers are located in wherever they are located.
Correct.
And they, we are in the data center business now. We are shipping racks as we speak. Each of the direct liquid cooled racks is typically around, 100 to 200 kilowatts of power. But it's also located in different places. And what if you actually start upgrading your own network? The mobile network that exists in the middle, you have devices that do inference, you have data centers that do inference and training. But in the middle, there's tons of processing that can be done.
Yeah.
Which means you have a need for energy efficient and high performance compute. The reason we say energy efficient is you cannot afford to bring in liquid cooled racks into this mobile network. At the edge of the network, you need AI accelerator cards. They need to be air cooled. Somewhere in the middle of the network, you can go with AI servers. They're also air cooled, not liquid cooled. And the power profile is different. Just to give you a ballpark number, devices, I would say order of magnitude 10 billion parameter models. Data centers, one rack, order of magnitude 10 trillion parameter models. Somewhere in between, accelerator cards, 200 to 300 billion parameter models, servers, 1 trillion. You have this continuum of compute that you can do this.
Yeah.
Now, this is where things get even more interesting. Some of the mobile operators are already sovereign data center providers.
Right.
It's easy for them to now start thinking of taking some of those assets and bringing them into the mobile network and becoming not just data providers, but also token providers. So they are in a different business now. So 6G for us is a lot of things. It's not just connectivity, but it's a connectivity, compute, and sensing.
Correct. No, that's fantastic. So to your point on the connectivity part on the AI glasses. So Reneo launched the first glass with eSIM, right? And we see that use case, and China Mobile has been talking about monetizing this. In fact, China Mobile and China Unicom actually invested in Reneo and to try to get more AI glasses, because as you said, the uplink traffic is growing bonkers, not only from the glasses, but also from the AI tokens, right? From the phones,
Yes.
right? So it needs a completely different type of network to manage the uplink traffic, right?
That's correct.
So I like the sensing part. I think there are a lot of use cases which can come out of it. And the processing part on the data centers. So I met SK Telecom, and they are exactly moving to that direction, what you're saying, right? So they want to get into a token business as well. They don't want to miss out on the boat, right?
Yes.
So all of this will be combined. But again, the common layer is going to be what we had been talking about before, is AI native, right? Which goes from the antenna in the base station right to the cellular phones and to the core network.
Yes.
Can you talk about more about what is AI native?
So the first, immediate answer to what is AI native, it means that the processing capabilities inside all of these different nodes within the network. At the bottom of the tower, that's your DU. In a DRAN configuration, you go a little further in, that's your CU. You have devices. Every one of those nodes must have efficient AI inferencing capability. That doesn't work with a traditional BBU architecture. And we are talking of like 100, 200, 300 billion parameter models going all the way to a trillion. You have to need a different kind of processing capability. As Qualcomm, we've invested heavily in that space with air-cooled based NPU servers and NPU cards. So that's like one of the things that they need to do. The other part is, well, what happens to the RAN workloads? Because you still have the more telco-centric layer 1, layer 2, and layer 3 processing. What do you do with that? One option is, hey, I have these GPUs. Let me just use those. We have a different view. We believe, first of all, there is already a transition occurring in that space where the GPUs that were built for training are not the best one for inference. This is our perspective, of course. Others might disagree, but this is our perspective. But secondly, you can't have a one-size-fits-all solution. From our perspective, we think that CPUs are even better when it comes to running RAN workloads, while the NPUs that we have and maybe some special purpose XPUs for inference are better suited. So what you have is a mix and match of at least a couple of processors which can handle RAN and AI workloads at the same time. Because you're going to have one server. In that one server, you run both RAN and AI workloads. Sometimes the AI workloads are in a discrete solution like an accelerator card. Sometimes they're integrated into it. But as Qualcomm, we provide the solutions, the silicon and the software, But we are working with practically everyone in the ecosystem. In this 6G press release that we did, it was historic in the sense, and I call it historic. I don't recall we finally landed with 58 partners in the entire ecosystem. And I was trying to think whether during the 5G days we had that much. Maybe we did, but that's a very, very large number. And when you see who are these partners, well, you have who you would expect, a lot of mobile network providers, they are there. But we also have infrastructure providers. Okay, they are also expected. But if you start paying attention to who else, well, we have the likes of, a lot of the new device providers, not smartphones, but glasses. They are also part of
robotics.
This. We have physical AI, based, some of the people from that ecosystem. Not to mention those who are already in the business of building servers.
Right.
This is a very different kind of a coalition. And one thing that we mentioned to everyone is, look, if you take a look at these three pillars, you might not play into all of them. Maybe you're focused only on sensing. Maybe you're focused only on that compute, and you might have solutions over there. It's okay. As Qualcomm, we are providing solutions that go into everything, which means you are a partner, regardless of one way or the other. But we also drew a line in the sand. As far as we know, to the today's timeline for 3GPP is such that the specifications are completed in the first quarter of 2029. So we said starting from 2029 onwards, because if that timeline holds, we believe that device launches can start from the second half of 29 onwards. But we said onwards, which gives enough flexibility for people to think about it. But we're not waiting for 6G standards to be complete and go from there. A lot of these investments, whether it's in compute, whether it's in glasses, or in sensing, the work has begun. But this press release was also intended to hold ourselves accountable and therefore have a milestone-based commercial path. Not something that we say we're going to launch in 29, then we show up in 29 and launch. No. Let's be concrete in terms of what is it that we want to show, prove to ourselves, and then show in 27, in 28. That makes the commercialization path a little easy.
So, with all this groundwork, I want to understand how it has changed over every generation. I know you guys have at a modem time which used to work on 3G, then 4G, 5G, but this requires a very complete different approach. So how are you allocating R&D for this? Is it different or is it the same thing?
In the last 5 years or maybe 6 years or so, we have changed as a company. We are a compute plus communications company now. A lot of emphasis on both, not just on connectivity. Very different from where we were like 10, 15 years back. And that journey has led us to a very diverse set of products. In fact, if you just walk around our booth, I would argue 15 years back, you would see a lot of connectivity based demos, some in prototype stage, some in commercial stage. Today, you walk around, there's an industrial robot, there is something which works in a factory setting, there's an entire rack from our data center space. Somewhere in the middle, we have a 6G based solutions which talks of agentic use cases in PCs and in XR. And then we talk about smartphones. And then there is a place where we showcase, okay, these are all the technology elements in that. This is a very different booth than something that was 15 years back. I think the diversification story that we've been telling, it kind of manifested itself in the booth that you walk around today. These are our products. These are not like just prototypes. A lot of them are our products. So our investments, hopefully, are beginning to pay off in all these different segments.
Brilliant. So on that strong R&D foundation, what I would like to understand is questions we get a lot from industry players, investors, your customers, partners is, okay, so Qualcomm has evolved from a great silicon company into a silicon plus software company. So now with 6G coming in and AI cutting across everything, so you have variety of compute, you have variety of connectivity, right? The AI stack required, right? How do you solve that problem of having a common software or at least optimized software stack for developers to build and leverage all the compute capabilities?
This is a very important question, by the way, and I'll spend like a couple of minutes on this. At the end of the day, if you are an AI developer anywhere in the world, you want to have an ease of use. That is your first KPI. This is not a traditional smartphone OEM who they actually have the expertise to go
Sure.
all the way in and go into the nitty-gritty details of power, performance, and area, and so on. This is a very different customer base that we are dealing with. So the one thing that we emphasized in our AI software stack is ease of use. And if you break down the stack, there's a silicon layer underneath. Then right above that, we have the initial software. By the way, we have multiple processors there between our NPU, our GPU, and our CPU. Right above that, you have all the software stack, but elements of it which are close to the hardware. These would be the compilers, the debuggers, the profilers, the way to actually test things. That is one level just above the hardware. Then you go one more step above that. That's where we work with our partners on frameworks and runtimes, whether it's ExecuteArch or /PyTorch or LightRT or WinML. We are open to everything. So any framework, any runtime, that's our real motto over here. And once you go on top of that, at the model layer, we are not a model creator.
Correct.
In fact, if you go to Hugging Face, there's like 2.6 million models out there. We want every single AI model on the planet to run efficiently on our platforms.
Absolutely.
And our platforms, when I say that, go from doorbells to data center. Everywhere.
I remember that.
We literally want that. To be able to do that, what we built is this framework, and therefore it's a far more open stack than anyone would imagine. This is not some black box that we provide. No, it's open. Okay. You pick whatever menu and recipe that you want, and then you go from there onwards. Similarly, on the data center, it's the same stack, same elements, but there's a little bit more. If you go to Hugging Face, with one click, we have a transformer library. With one click, you go from that model and you can immediately test it on how does it work in our rack. It starts with cards and goes into racks as well. So we've invested heavily in ease of use. Again, 10 years back, we were very focused on our OEMs where we would sit down with them and then go through with it. But there was nothing that was, very visible and open about it. But today we deal with developers in the industrial sector, in the automotive sector, in PC segments. There's so many ISVs that are out there. We can know which model is picked by which developer, which runtime they pick, which platform they pick. We just kept it open. Anyone can pick any one of those things, and we make sure that it runs efficiently.
I think there's a time for branding that particular stack. Like some of your competitors have branded, but I think that will also make it easier to understand the moat and the breadth and depth of it.
I think there's, this stack that I mentioned, because of the fact that it is modular and it is also open,
right?
A lot of the hyperscalers are our partners. We actually work closely with them. They have their own stacks too. So the way we work with them is pick your elements from our stack.
Okay.
If you are the one who's eventually providing that service, pick what you want. You might say, I want nothing. I got my own.
That's brilliant.
That's never the case. Usually they say, I'll pick the following, and then go from there onwards. And there are those who say, no, I just want the whole solution.
Yeah.
So we've kept it flexible so that anyone can pick that. And in that sense, I think that flexibility is going to be key moving forwards in AI stacks.
Thank you very much. This was very insightful. I learned something new as well. Thank you very much, Durga, as always.
Nice to talk to you. Yeah, bye then.